Recording in progress.
So in our previous class, we have learned about series LCR circuit, quality factor, bandwidth, etc. like kind of terms. In our class, I will deal transformers. With this, I will conclude the theory today. As far as problems are concerned, you have two set of problems available. One is the some collection of previous exams, and the other is class test. Okay, right. Make sure you complete it. Last 1 hour, I'll start allowing you to work so that you make sure that you complete this too. Compulsorily, transformer works only with alternating current, not direct current. Second point, transformer works on the basis of the principle of mutual inductance. Actually, the term transformer is derived from transfer of power. Transformer. You are seeing two different set of transformer, two different types of transformer. All this is data borrowed from NCERT. Two different types. See, in this, what you can see is two different arrangement. In one arrangement, one coil is over the top of the other. Common core transformer. The first one, common core transformer. The second one, you can see that they are wound on separate limbs of the core. Common core and a separate arrangement here. What is the criteria? You know, when the flux linked with the secondary due to the current in the primary undergoes changes with the time, and EMF is induced in the secondary, and if the secondary coil is closed, a current flows through. This is the principle of mutual inductance. We are using the same over here. Already last class also I have introduced mutual inductance, and I have discussed one problem, very latest IIT question. Remember, this week you are about to get that question. Right. The basic understanding, I'm just dealing basic understanding. In IITs, only once they have given a question on transformer. Till now, that too almost long back, at least I can say more than 10 years back. More than 10 years back. Even mutual inductance also, I told you, mutual inductance based question, you got once in 2016, earlier 2020, now 2026. Mutual inductance based. Therefore, you need to learn from the basic, but in mains, the asking rate is high. Every question paper may contain transformer question. That is the formula type question. What I will noticing is there are the basic understanding of the transformer, right? Under basic understanding, you can see that this is the primary part of the circuit. This is the secondary part of the circuit, and where I am drawing the load from here. So for this purpose, I am taking NP as the number of turns in the primary. NS stands for the number of turns in the secondary. Primary, secondary. Primary is the source side. Secondary is the output side. Any doubt till this point? Any doubts till this point? Asking again, any doubts till this point? Right. When I am setting the alternating current here, the flux changes, and in fact the flux linked commonly with these two coils also changes, and this change involves an introduction of EMF in the secondary coil. Right. In an ideal transformer, under completely ideal conditions, the n number of flux lines of primary is totally linked with the secondary. All n lines, magnetic lines of primary is linked with secondary under ideal conditions. Sometimes there may be flux leakage. But ideal conditions, the flux linked with the primary is same as the flux linked with the secondary. Any doubt? Boys and girls, this is a valid point and I will ask this point later on. Any doubt on this? Any doubt on this? I'm asking again. Right. Now, what is E secondary? What is the source for E secondary? There is no battery in secondary. The only source in the E secondary is NS d5 by dt. Okay. See, across this, whatever that I have applied is, it is like, I can imagine that it's like a pure L circuit. Whatever I am applying, that is LDI by dt or d5 primary by dt. Per turn, there are n turns, NP d5 by dt. Okay. Even secondary also, per turn EMF source is d5 by dt. There are ns number of turns, each turn acts as a source, and hence the EMF, effective EMF induced in the secondary is ns times d5 by dt. Now, from these two equations, yes, you convinced me d5 by dt is the same. I can say V secondary by V primary is N secondary by N primary. N secondary by N primary. Any doubt on this, boys and girls? Yes, yes.
But in that equations, why aren't we considering the self-inductance of the coil, sir? Should we consider or should we not?
D5 లో వచ్చిందిగా.
D5 లో మొత్తం మీరు మొత్తం తీసుకుంటారు. సెల్ఫ్ ఇండక్టెన్స్ వల్లనే ట్రాన్స్ఫార్మర్
D5 ఉంటుంది కదా. So I am not now linked with L1, L2, M turn. I'm just mentioning voltage in secondary, voltage in primary, number of turns in primary, number of turns in secondary. We will do that in problems. As far as transformer is concerned, even in NCERT also, they never touched L, M term. We will do that in numericals, right? V secondary by V primary is equal to N second. This is the working principle of the transformer. Again, I am saying this is ideal transformer. Now, applying this equation, we require certain assumptions. First assumption is, in the primary, there is no resistance. A primary resistance in the primary coil is very, very small. And we are assuming current is also small in that. Because loss is high. Suppose even if elemental resistance is there, a loss is high in primary. Second point, while I am applying this, I am cancelling these two terms, don't forget, which is possible only when the flux linkage with the secondary, flux linkage in the primary is the same. Okay, right. Even practical purposes, ideal conditions, the secondary current also must be less. Otherwise, there is a power loss. So power input is power output. That is ideal transformer. Power input is power output, but there will be loss. That I will discuss very minutely, and I will also discuss some numericals related to this. Technically, they are direct NCERT questions. I'll discuss that. No issues. If the transformer is 100% efficiency, efficiency always means output by input. If input power is same as output power, of course, ideal conditions, we say that is 100% is efficient. What is power? Anytime. I primary, V primary is the power in the primary circuit. I secondary, V secondary is the power in secondary circuit. So I am equating the powers. I had a fresh equation here. I had another fresh equation here. Cumulatively, I can say V secondary by V primary is same as N secondary by N primary is same as I primary by I secondary. Remember, this is the working principle of the transformer. I repeat, this is the working principle of the transformer. And one more important point, the AC of primary is same as the AC delivered in secondary. So therefore, their frequency is also same. That is also there. ఇది చెప్పాలంటే there are in mains theory type questions a lot of times it appears. While you are writing grand tests or while you are writing the original papers, you are expected to do. Entire mains, they will ask only this condition. If it is application. Entire mains. If a question comes from transformer as a number, that's all. That's the deal. Right. So, sometimes what we do is, if number of turns in the secondary is greater than number of turns in the primary, what happens? You already written one thing, V secondary by V primary is N secondary by N primary. You already written this. Okay. So, in this case, if N secondary is greater than N primary, V secondary is greater than V primary. N secondary greater than N primary. V secondary greater than V primary. I primary is greater than I secondary. This is what we will call as step-up transformer. At power stations, this is what we will do. So we will send the current, AC current, by stepping up high tension wires. What do you know? 10,000, 20,000, 50,000, etc. Because so higher the voltage, least is the current, least is the loss. That I will discuss very next step. Okay. So on the other hand, V secondary by V primary is equal to N secondary by N primary. If N secondary is less than N primary, V secondary is less than V primary, I secondary is greater than I primary. This is called step down transformer. From the main line to the substation, substation to our streets, it will be step down. For example, power station to the transmission station, if it is made 50,000, for example, from transmission to local substation, it may cut down to 50,000 to 1,000. And from substation to our street, there will be another transformer. And there they will cut down to 240 or 220 volts, 58 JC. That is what we will receive at our house. I think you got my point. So therefore, step up is required at the power station, step down is required at our houses. Even while you are charging your phone, you are using a transformer, whether you know it or in your charging port, whatever the adapter that you are using, head, in that head you will have a transformer. Remember, you are drawing current from an AC source. When you are plugging in, you are drawing current from AC source. Your battery gets charged by a DC current. How is this possible? There will be a transformer. And that will do step down. Hardly require 5 volts, not more than that. So it will be converted from AC 220 volts to 5 volts DC. And again, there will be rectifier circuits inside in that. The rectifier circuits will make it a steady DC, and that DC we are using to charge our batteries. Any doubts? Okay, clear? So therefore, basically what is that you need to understand is you are using charger, implies even my power cord also, laptop power cord, same. All electronic instruments which you are using in your houses, TV, computers, all that, you will see a transformer. Okay? So the transformer which you see outside your apartment, a bigger size version, a very mini version of transformer you will see in your charging point. Principle is the same. Now, till this point, any doubt? For a student appearing for mains, this information which I am giving is more than sufficient. Right. Then the problem is, are all the transformers ideal? No. There will be loss. What are the different types of losses? Everything is borrowed from NCERT. So you don't require to study again separately NCERT related to AC chapter. Right. Sources of energy loss. First, flux leakage. If there is flux leakage, the problem is input power is not same as the output power, because you are not delivering that much EMF to the secondary. That comes under flux leakage. There is always some flux leakage. That is, not all of the flux due to primary passes through the secondary due to poor design of the core or the air gaps in the core. Okay, that can be reduced. It can be reduced by taking proper winding the primary and secondary coils one over the other, which I have shown in the diagram in this arrangement. Right. Next.
Can also be increased by putting a flux linkage.
Flux?
Linkage. Flux linkage.
అదే కదా ఎట్లా లీకేజ్ చేస్తాం.
లాస్ట్ టైం పెట్టినప్పుడు ఒక స్టీల్ బార్ రెండు ఇండక్టర్స్
అదే కదా చేసింది ఇదిగా.
వైండింగ్ కాకుండా కూడా చేశారు కదా.
చేసాం. ఇదే ఇది స్టీల్ బార్, ఇది మేర్ ఆఫ్ మెటల్, సాఫ్ట్ ఐరన్ కోర్. దేని చుట్టాం ఇది. దిస్ ఇస్ కాయిల్ 1 and the other one is coil 2. Okay, right. Next, resistance of the windings. I said ideal conditions by one of the point is the resistance is less. How come resistance is less? When you have winding wires, when you set 1000 turns are there, obviously that is some length of the conductor. Obviously it will have some resistance. So the wires used for windings have some resistance, and so energy is lost due to heat produced in the wire, that I square R term. So in high current, low voltage wirings, these are minimized by using thick wire. That is the only option. But if I use thick wire, size will become more robustic. Size will become robustic. Resistance తగ్గించమన్నాం, number of turns compromise కావు. What option do I have? Tell me. Increasing the area of cross section of the wire. That reduces the resistance. That reduces, not eliminates. Next, eddy currents. Suppose if it is a thick block of iron, for example. Suppose this is a thick block. You are seeing this in a 2D mode. In a 3D mode, how it looks like? That is how it will look. So this is a thick block. This is a thick block. Then all that is a single thick block. What happens? Eddy currents will come to rise. So how to avoid eddy currents? Tell me. Don't use thick block. All such, you make plates, plate to plate gap, you paste it with an insulator, right? Okay, you take 100 such plates. Okay, I'll try to demonstrate that. I don't know how good I am in that.
Is it economically feasible to put 100 plates?
Only those who require will buy.
last week ఒక వీడియో చూపించారు సెకండ్ కరెన్స్
Ah,
ఆయన ఒక మెటల్ ప్లేట్ తీసుకుంటాడు ఇంకోటి పోరస్ ప్లేట్ తీసుకుంటాడు ఇట్లా మధ్యలో
Ah.
కలుస్తున్నాడు.
ah.
అది మననే transfer
అదే చేస్తూ-
చేస్తున్నాం.
ఆగలేడు వాడు.
And that's the insulating.
అలా పోరస్ పెట్టాడు అనుకో, ఫ్లక్స్ లీకేజ్ అవుతుంది. ఇప్పుడు మీరు యూ కెన్ సీ దిస్ ఫస్ట్ పార్ట్. Just want to just show you that. You can see the first part very clearly. It's like slides type of arrangement. You can see here. I think you can see here now. The single lamination diagram. Single lamination. You can see that, no? Here. Single lamination. How you are, yeah, you see the right side part right now. Laminated core. Have you understood this one? Here, this one. Laminated core. So now what will happen is a slide. Likewise, of course, there is a thick block. This is a thick block, undoubtedly. Okay, to accommodate zero flux wastage. But eddy currents will not spread in that, because from the first slide to second slide to third slide to fourth slide, there is gaps, lamination. So that will spoil the flow of eddy currents. Okay, right. So now you see core type construction. There are two types. Core type transformer. This is a core type transformer. Right. So I just want to show you that laminated part, laminated core. Right. So the eddy currents can be eliminated by using transformer cores with a laminated plates. Okay, but still there will be, but maximum we can avoid, reduce otherwise. Hysteresis. Hysteresis is not known to you because it's a property related to magnetism. So in the process, because of the directional changes, this material gets magnetized in one direction and again demagnetized the current while it is changing its direction. This process involves some loss, and that loss comes under hysteresis. So the hysteresis loss can be minimized by using a material called soft iron material. So most of the transformers, they will use soft iron material to reduce hysteresis loss. Again, flux leakage resistance of the windings, eddy currents, and hysteresis. These are the 4 different types of losses. Apart from this, the large scale transmission and distribution of electrical energy over long distances, of course, is done with the use of transformers. How? The voltage output of the generator is stepped up so that the current is reduced and consequently the I square R loss is cut down. Right. It is then transported over long distances to an substation near the consumer. This is already just informally, but anyway, formally I'm dealing this. Here the voltage is stepped down. It is further stepped down at the distribution substation and utility poles before a power supply 240 volts reach our homes. We work in India around 240 to 220 and 50 hertz AC. Right. The NCRT questions, I'm just exposing you. A power transmission light feeds input power at 2300 volts to a step-down transformer with its primary windings having 4000 turns. What should be the number of turns in the secondary in order to get an output at 230 volts? What have you given? What have you given in this? In fourth, what is this 2300 corresponds to? V primary is given as 2300 volt. Okay. A step down transformer with primary windings. N primary is given as 4000. What should be the number of turns? N secondary, how much? V secondary is equal to 230 volts. Same question repeated n number of times in main section. On formula. Any doubts? Any doubts, boys and girls? Right. Now you see another question. An idle hydroelectric power plant. So I told you 3 types of power plants in my very first class. One is hydroelectric power plant, thermoelectric power plant, nuclear power plants. Tidal, wind, etc. That's all a different game. Right. Anything that mechanical energy is converted into electrical energy. That is what happening. Something will rotate the armature, and because of the rotation of the armature, EMF or a current is generated. That's all. Right. But majorly in India, 60% is still on thermal. 60%. Right. So we are good at carbon emissions because of that. Right. At a hydroelectric power plant, the water pressure head is at a height of 300 meters and the water flow available is so and so. Rate of flow is what they have given. If the turbine generator efficiency is 60%, only 60% of the mechanical energy lost is converted into electrical energy. Estimate the electric power available. See, try to please understand, you can convert rho GH into V. Rho GH into V. Yes. Rho GH is pressure into V, right? But this is not volume per second. So that PV will now become power. In fact, I can say power, energy lost per second. So energy lost per second mechanically is rho GH into V. Okay. Out of which 60% is the output power. So the output power is 176 megawatt. Decently good. That's fine. Small town can survive on that. Okay. Any doubts? Is input power. This is input power.
Into 0.6.
into 0.6 is output.
Output అన్నది.
ఇదేగా అవుట్పుట్. Electrical generation happening from that loss is maximum 176 megawatt. Boys and girls, any doubts? Boys and girls, any doubts? Any doubts?
ఇందాక ఇండియా ఇస్ అ గుడ్ సోర్స్ ఆఫ్ కార్బన్ ఎమిషన్ అన్నారు.
అవును.
థర్మల్ పవర్ ప్లాంట్.
Yes, because of thermal power.
మొన్న థర్మల్ పవర్ ప్లాంట్ అంటే ఏం ఎక్స్ప్లెనేషన్ ఇచ్చారంటే
Thermal power అంటే coal or gas?
coal or
Gas. ఏదైనా కార్బన్ ఎమిషన్ ఉంటుంది.
మీరేం చెప్పారంటే స్టీమ్ వల్ల ప్రెషర్ హై క్రియేట్
ఒరే ఒక్క నిమిషం, నువ్వు సగం పాయింటే విన్నావు. కోల్ ఆర్ గ్యాస్ బర్న్స్ వాటర్, హీట్స్ ద వాటర్, కన్వర్ట్స్ టు స్టీమ్. ప్రిన్సిపల్ ఈస్ ద సేమ్. ఓకే, సో వై చైనా ఈజ్ హ్యావింగ్ 65% ఆఫ్ రెన్యూవబుల్ సోర్సెస్? బికాస్ maximum hydel. Maximum hydel. They don't get solar as what we get. We are very much 70% of our, see, even solar also, I learned somewhere long time back, solar also not preferable at all the places. See, sun's illuminance, the light that we receive per second, is different at different places. It has to be a threshold value to place solar cells. Fortunately, India, we have n number of places where you can use solar. For example, take total Rajasthan and Gujarat. You can comfortably use that place. Even in Telangana states also, we require some plain areas for that. There are n number of places. Suppose there is no cropping, that soil is not useful for cropping. Okay, so you can use that for solar panels. In Andhra Pradesh, some areas in Anantapur, Kurnool, etc., they are not good for cropping. In the sense, water facility and all that is very scarcity. Scarcity is high. Water availability is very less. There you can use solar panels. For example, if I am using 1 acre land with a solar cell, like for example, 1 acre land, suppose if my capability is producing per day at a rate of, say for example, 1 megawatt, for example. Okay, so I am selling this for the government, and government pays for me that. A 1 kilowatt hour is 1 unit. One kilowatt hour. Now we have 10 hours. We are running this. Okay. 1 kilowatt hour into 60 minutes. So I am running, say, sunlight may be maximum on an average available only 8 hours. 8 into 60. So 1/8 kilowatt hour units I can generate per day. Ante kada. See, 1 kilowatt hour is 1 unit. Actually, I heard that a solar cell of the size equal to a solar cell of the size equal to 10 into 11 area will generate a power of 1 kilowatt. One kilowatt. So per day, which means I can say square yards prox. Square yards, say for example, if it is a 9 into 10, for example, which is convenient, 9 into 10 square feet. If I convert into 10 square yards, 9 into 10 square feet is 10 square yard. 10 gajalu. 10 square yards, 1 acre is nearly 5,000 square yards. And 500 times. And 500 kilowatt. Suppose 500 kilowatt capacity undi neeku. Okay. So, you have 10 such acres. 5 megawatt. And 500 kilowatt into 10 is 5,000 kilowatt, 5 megawatt. You sell this for the government. Suppose using 1 such plate, I can produce 100 units per month, for example. Okay. I am producing 100 units. Even I take the basic unit fare, 2 rupees, for example. Actually, whatever that we are getting, the power is very much subsidized by the government. Very much subsidized by the government because they are giving freebies for a lot of. So therefore, on an average, you take 2 rupees per unit, which is very low. I am calculating. So in a month, because that I am producing with the 10 square yard plate, on an average, I am producing 10 into 2. 10 into 10 square yard. I am earning some 200 rupees. 10 square yard plate I am producing 100 units per month, for example, by solar. So I am generating an amount of 200 rupees. ఇప్పుడు నేనేమని చెప్పాను ఇంటూ 1 ఎకర్కి వచ్చేటప్పటికి ఏమవుతుంది ఇంటూ 500 times 500 into 200 ఎంత 10,000. So per acre per month earning is 1 lakh కాదు 500 into 200 1 lakh 1 lakh per acre you can earn 1 lakh. Okay, practically walking distance etc, all that, even if it is 50,000 per month also, it's a good revenue for you. Okay, but installation cost etc like kind of thing are to be considered one-time investment. That's a one-time investment. Inka, he can install it a bit higher side. He can use for normal cropping, chinna crops vesukovachu kinda. Low sunlight lo run ayyevi vesukovachu. Tomatoes, పచ్చిమిరకాయలు అట్లాంటివి కూడా వేసుకోవచ్చు. Solar. In China, they have limited resources related to solar side. We have very high resources. Even pump sets will run on solar cells in India. They don't require external electric power. The problem is free, everything free. నా బోటుగాడు పోయి ఇది కొనుక్కోండి అంటే కొడతారు కూడా దీనికి అలవాటు పడిపోయినా. రైట్, దిస్ ఈస్ ద క్వశ్చన్ which will give you a complete picture of the working of a transformer. Everyone try to please go through this question. A small town with a demand of 800 kilowatt, chinna town 800 kilowatt of electric power at 800 kilowatt ante oka hour to multiply cheyandi. For example 800 units per hour is required. అంతేగా, 8 kilowatt అలాగా తప్పు చెప్తానండి. ఇంటూ 60 వేస్తే ఇంటూ 60 చేయాలి అనుకుంటా. కిలోవాట్ అవర్ కదా, 1 hour వేస్తే అంతే, రైట్. 800. ఈ 800 units per hour I need to provide. Small town, చిన్న పల్లెటూరు line. Electric power at 220 volts is situated 15 kilometers away from an electrical plant, generating power at 440 volt. The resistance of the two wires, yes, obviously this is the power plant. This is the primary transmission line. And again, this is where there are two transformers involved. This is one step-up transformer. This is the one which is step-down transformer. These are transmission lines. And they have resistance 0.5 ohm per kilometer. The town get power from the line through a 400 220 step-down transformer at a substation in the town. So have you understood the complete picture of the question in the first paragraph? Forget about questions. Information, have you understood? Primary 4000, secondary 220 volts. V primary, V secondary.
సార్ అలా ఈవీ అవి డిఫరెంట్ ఉండదు
ఉండొచ్చు.
ఒకటే సర్క్యూట్
ఏవి
442 వీటీ స్టెప్ అప్ అయింది కదా
అవును.
అది అంటే
ఈ ట్రాన్స్ఫార్మర్ వేరు, ఈ ట్రాన్స్ఫార్మర్ వేరు.
మన సర్క్యూట్ ఒకటే కాబట్టి
అవును, ట్రాన్స్మిషన్ లైన్స్ ఉన్నాయి కానీ ఇంకా.
ఓకే
Right. Right. Estimate the line power loss in the form of heat. First of all, what is given? 80 kilowatt of electric power. Power is known, voltage is known. Right. First of all, power delivered to the down, 800 kilo. 800 into 10 power 3 into, that is power. That can be written as you are delivering here. This is the delivering point. Hello? That is the delivering point. At this point, you are delivering a power of 8,800 kilowatt. What is this 800 kilowatt? I am assuming there is no loss in this. There is no power transmission lines. Right. So 800 into 10 power 3 is 4,000 times at the delivery point. So current is 200 amps. 200 amps is not a small current. It's a big current actually. Right. So what is the line power loss? Try to please understand this line and this line together. The resistance what they have given is 0.5 and the to and fro distance is 30 kilometers and 0.5, so 15. So when you do the I square R term, you will get 600 kilowatt loss. Purely heat, which means in this lines you are losing 300 kilowatt, 300 kilowatt, and you are delivering 800 kilowatt. So totally what I am receiving here, 600 plus 800, 1400. Arey nenu 1400 kilowatt receive cheskuntenega loss 600, transmission 800 ayyedi. So where am I receiving this from? From the primary of the source. So what information that I know? This is 1400 kilowatt. 1400 kilowatt. Hold on, 1400 kilowatt. Okay. 1400 kilowatt and V here 1400 kilo by current. So what is the power delivered here? 1400 kilowatt is transferred. So 1400 kilo by current gives 700 volts, which means in this transformer, this secondary voltage is 7,000 volts. But they have provided one more information. Power generation is 440 volts. So therefore 440 volts, 7,000 volts transformer is what I am using. Right. Now tell me what is that you want in this question. Please go through this question. In the first case, I have identified what is required here. In the second case, I have identified the current in this loop. On the basis of the current in this loop, I have estimated the drop across this point, the secondary, V secondary. Okay. Any doubts? I'm asking you again, do you have any doubts?
అక్కడ మధ్యలో ఉన్నది నార్మల్ రెసిస్టెన్స్ ఇక్కడ తీసుకొని వీటి ఓమ్స్లో బట్టి
వీటి ఎక్కడ ఓమ్స్ లాగటి
వీటి మైనస్ 4000 ఈక్వల్స్ టు ఐ.
ఇవి ఏసీ కరెంట్స్. ఐఆర్ ప్లస్ అలా కట్టలేం కదా. These are AC currents.
లాస్ట్ టైం స్టెప్ ట్రాన్స్ఫార్మర్ ఫస్ట్ ట్రాన్స్ఫార్మర్
ఇక్కడ నీకు ఎంత వచ్చింది? ఇక్కడ 1400 కిలోవాట్ పవర్ రిసీవ్ చేసుకుంది ఈ ఏరియాలో. ఆల్రెడీ ఇందులో కరెంట్ వచ్చేసి 200 amps. సో ఐ కెన్ ఎస్టిమేట్ ద వోల్టేజ్ హియర్ V secondary. V secondary is 7000 volts. And at that point of generation, already they have given in the question 440 volts. So 440 volts to 7000 volts is a step-up transfer. Any doubts? Any doubts?
Small clarification, sir. If secondary circuit ఉంది కదా, secondary circuit లో ఎంత పవర్ అయితే డిసిపేట్ అయిందో అదే దాంట్లో కరెస్పాండింగ్ ప్రైమరీ దాని అంతే పవర్ డిసిపేట్ అయింది కదా.
ఎందుకు కావాలి?
Sir,
నువ్వు ఇక్కడ డెలివర్ చేసింది 1400 కిలోవాట్, ఇక్కడ డెలివర్ చేస్తుంది 800 కిలోవాట్.
అలాగే సార్, దాని ముందు సర్క్యూట్ లో ఇప్పుడు
దీనిలో అసలు లాస్ నీకెందుకు కావాలి?
దాంట్లో 800 కిలోవాట్స్ మనకు కావాలి.
రైట్ సైడ్
రైట్ సైడ్.
అలా కాయిల్ ఉంది కదా సార్, అంటే రైట్
ఇదే నువ్వు అడిగేది?
అది కాదు దాని పక్కన.
ఇదే నువ్వు అడిగేది?
దానిలో ఎంత లాస్ అవుతుందో దాని పక్కన దానిలో కూడా అంతే అంతే పవర్ జనరేట్ కావాలి సార్.
అదేగా నేను రాసింది.
అదే క్లారిఫికేషన్.
అదే ఓపిక ఉండాలి. రైట్. డూ ద సేమ్ ఎక్సర్సైజ్ as above, same question, with the replacement of the earlier transformer by 40,000 220 volt step down transformer. Neglect as before. Leakage losses through this may not be a good assumption any longer because of very high voltage transmission in. Hence explain why high voltage transmission is preferred. What is current? Same 800 kilowatt by 40,000, that is 20 amps. Any doubts? Hello? Any doubts? Previously you said 4,220 volts. Now you changed that to 40,220 volts. So this makes a current of 20 amps. So what is the transmission loss? 6 kilowatt. You are delivering 800 kilowatt and the loss is 6 kilowatt. So what is happening over here? When I am giving 806 kilowatt here, 800 kilowatt is a transfer. Why we are using high voltage? Because of this reason. Okay. Now, by the way, everything is good. Now you know the current 6 kilowatt. Now you know the power received at the primary, at the first transformer. I have received a power of 806 kilowatt and the current here is 20 amps. This allows me to determine voltage. And that voltage is 40300 volt. So what is your transformer at the power generation point? 440 volts. 40.3 kilovolt. Yes.
Power production 812 now.
40,000.
I square R 20, 20, 15. 2R 15 వచ్చింది. ఇందాక కూడా 2R అదే చేశాను. ఇదిగో I square R. Both the lines together is 15 ohms. Actually, 15 ohm is also very practically small. When the current is that much, see, that is the reason why we are transferring power from low voltage to very high voltage. That allows us less current. That allows us not the percentage of transmission to town, you see. Now you are transferring 800 by 806 into 100%. What is this nearly? Anyone in the class? That's it is 90% plus. 98% is a calculator base. Calculator base.
99.25.
800 divided by 806. This is nearly 99.2%. Whereas in this case, 800 kilowatt by 1400 kilowatt.
57%. 57%.
This is literally 57.1%. 14, literally 57% is. Got the point? So what is adaptable? Best method is high voltage transmission. High voltage transmission is best adaptable for us. Okay? Right. With this, I have done total, theory part. AC generator is the very first class which I have done. How AC current is produced is what we will call as AC generator. Right. Now, I am interested to deal one problem with the transformer. The same question given as it is, same question given in other books also. The Pathfinder question. If I am not mistaken, that's the only question. Okay. Anna, Adichana. Right. Suskondok, sir. That is the only question in Pathfinder which they have given a question on transformer and a easy question also. Practically, a very easy question also. No issue. Everyone try to please go through the question. Print తీయలేదనుకుంటా లాస్ట్ పేజ్. కనిపిస్తుందా స్క్రీన్? There are you listening? Following? 3 identical coils. Identical means their self-inductance are same. three identical coils. An alternating voltage source is connected across the coil A. Okay. Ideal voltmeter is connected. Ideal means open, honestly. Okay. Case 1. Case 1. Left open. Which means coil B will not contribute any mutual inductance to either A or C. Agreed? Boys and girls. So what is the first case? I2 is equal to 0. Ram Kartikeya, any doubt? Any student in this class having any doubt? Remember, I did not step into the question. I did not started solving the question. What I am doing at this point of time is trying to analyze or encrypt the data properly. Any doubt till this point? Satvik, Ritvik. Any doubt? Riddhi. Right. And one more identical See, one thing that I need to consider, one more point is coils have negligible resistance. You don't require to inform under ideal conditions of a transformer. I already started this. Winding coils resistance is negligible. So before I am getting into the question, I am starting deep analysis of the situation. Right. Now, what is happening? What is that? There is no mutual inductance terms in this case totally. So whatever the voltage applied by AC source called V1, I can simply write it as LdI1 by dt, equation 1. Any student having doubt on this? Okay. Now, one more important point. This is, you have to see what is happening. V3 is equal to, let us see, LdI3 by dt plus MdI1 by dt. Why you are looking at me? This is what available. And this is 0 plus m di1 by dt. And that is given as v1 by 2. Given in the question. Before I step into the next stage of the problem, I want 100% confirmation from every student of this class. I want 100% confirmation from every student of this class. Clear? Any doubts? Any doubts? Boys and girls. Any doubts? Sushita? Right. Is this giving me any information? Let this be equation 2. Equation 1 and equation 2 implies m is equal to L by 2. Remember, we need to use this in time of need. Okay, so that is a valuable information which I got. Right. Now we will go to the second part of the question. How much will the voltmeter read if the coil B is short circuited? Which is this one. Coil B is short circuited. At this stage, let I2 corresponds to current in coil B. Right. Any doubt? Now tell me carefully. Now every step is very careful. You need to write very carefully every step. What is V1? What is V1? Ram Karthikeya.
di by dt plus mdi2
Jartaga with terms proper.
di by dt.
Wrong. What is DI? Cross check cheste paristhiti adi. Adu ventalla. Same question you will ask at the end of the question. Check. What is V1? I1, say current in coil A. Now tell me. What is V1? There are no complete DI by dt and నేను రాస్తే ఊరుకుంటాను తర్వాత ఏమని అడుగుతావు వాట్ ఈస్ DI by dt అని నువ్వు అడుగుతావు మెహర్ వాట్ ఈస్ V1 LDI1 by dt ప్లస్ చేయాలా మైనస్ చేయాలా అవును అన్ని ఫ్లక్స్ లింక్డే కదా సేమ్ సెన్సే కదా ప్లస్ honestly speaking I should write mdi2 by dt plus mdi3 by dt but I3 0 కాబట్టి this is the picture. So finally LDI1 by dt plus L by 2 di2 by dt. Let this be equation 3. Any doubts in equation 3? I'm asking again. Do you have any doubts in equation 3? ఎందుకు చెప్పాలి? Why? Same flux is passing through. What is mutual inductance? ఆ కేసులో ఎలా చెప్పాను నేను మీకు? If the flux sense is the same, plus m రాస్తారు. Flux opposite direction లో ఉంటే minus m రాస్తారు. సేమ్ సెన్సే అన్ని టొరాయిడ్ చుట్టే తిరుగుతున్నాయి లైన్స్. టొరాయిడ్ లో ఓకేనా ఇప్పుడు ఎట్ అన్ ఇన్స్టెంట్ అనుకోండి అది మళ్ళీ ఎప్పుడు అలా తిరగదు అట్ అన్ ఇన్స్టెంట్ ఎందుకు నువ్వు ఇచ్చేది ఏసీ ఎందుకు అయిపోతుంటుంది పాపం కాయిల్ ఏ కాయిల్ బి కాయిల్ సి ఇప్పుడు చెప్పండి మ్యూచువల్ ఇండక్టెన్స్ ప్లస్ మైనస్ రైట్ నెక్స్ట్ క్వశ్చన్ ఏది రాయమంట ఎలా రాస్తా I1 I2 I3 ఇది రాయాలి ఇది ఏసీ కదా అయితే దాన్ని బేస్ చేసుకుని అట్ అన్ ఇన్స్టెంట్ బట్టి తీసుకోవాలి ఏసీ డోంట్ ఫర్గెట్ దిస్ కీప్స్ చేంజింగ్ ట్విస్ట్ ఏంటంటే V2 వాట్ ఈస్ V2 దానికో ఎల్లో ఉంది ప్లస్ మామూలుగా అయితే M di3/dt కూడా రాయాలి బట్ దిస్ ఈస్ 0 మీకు విషయం చెప్పనా ఇది కూడా 0 కావాలి బికాస్ దెర్ ఇస్ నో సోర్స్ ఫర్ బి దెర్ ఇస్ నో సోర్స్ ఆఫ్ EMF ఫర్ బి అది ట్విస్ట్ స్టెప్ ఇప్పుడు చెప్పండి LdI2/dt is minus MdI1/dt. సో వేర్ ఎవర్ ఐ హ్యావ్ di2/dt ఇది చేస్తూ ఉంటే ఏమైనా గుర్తుకొస్తుందా ఇది చేస్తూ ఉంటే ఏమైనా గుర్తుకొస్తుందా ఇంత దరిద్రం ఉన్నారు మన క్లాస్లో వాడి ఇంక్లూడింగ్ బాల్ ఇది చేస్తూ ఉంటే ఏమన్నా గుర్తుకొస్తుందా అని అడిగాను లాస్ట్ వీక్ అడ్వాన్స్డ్ క్వశ్చన్ ఇలానే చేశారు లాస్ట్ వీక్ చెప్పాను నేను క్వశ్చన్ ఇప్పుడు చెప్పండి పాత్ ఫైండర్ క్వశ్చన్ ఎందుకు రాలేదు అక్కడ ఈ క్వశ్చన్కి ఆ క్వశ్చన్కి తేడా ఏముంది ఎస్ ఆర్ నో సేమ్ పాత్ ఫైండర్ క్వశ్చన్ ఎస్ లాస్ట్ వీక్ వాట్ ఐ హ్యావ్ డిస్కస్డ్ వన్ క్వశ్చన్ ఇన్ యువర్ క్లాస్ సేమ్ right so finally what finally V3 V3 what is V3 LD మామూలు మన ఫార్ములా అయితే LdI/d3 ప్లస్ M di1/dt ప్లస్ MdI2/dt మనం ఫార్మల్ గా దీన్ని ఏం చేస్తాం 0 లే సో V3 చేస్తారా బాబు ఫస్ట్ ఒక్కొక్క టర్మ్ దిస్ ఈస్ ఆల్ 0 సో therefore L/2 di1/dt plus L/2 di/dt is minus 1/2 di1/dt. అరే మనం వోల్ట్ మీటర్ రీడింగ్ మనం కడతాం అది షార్ట్ చేసేసావు కదా Coil B is shorted. Coil C, it is still voltmeter and it's open. Right, thank you. Thanks for following. L by 2 di1 by dt minus L by 4 di1 by dt is L by 4 di1 by dt. Do you know what is this part?
V1. So final question.
ఆగండి ఇప్పుడు ఈ V1 కూడా this one is also need some require modification, no? L di1 by dt di by d2 di2 by dt ఏమొచ్చింది మీకు? V1. So therefore finally this is ఇప్పుడు నువ్వు నన్ను ఏమడిగా ఇందాక క్వశ్చన్ ఎల్లులు ఉంటాయి ఎమ్ములు ఉంటాయి మీరేం మాట్లాడరే. సో దిస్ ఇస్ హౌ వి విల్ ఎల్ ఎం టర్మ్ దిస్ ఇస్ హౌ విల్ హ్యాండిల్ ఇన్ ఎ ట్రాన్స్ఫర్. ఎనీ డౌట్స్? ఎనీ డౌట్స్? ఎనీ డౌట్స్? ఏ కేసు 1 లో I1 కేసు 2 లో I1 సేమ్ కాదు. That's the reason why I have done differently. Only part which I am using is mutual inductance. వాడికేమో క్వశ్చన్ కావాలి, నీకు ఆన్సర్ కావాలి. నేను తరపాలి ఇక్కడ కూర్చొని. 1 minute. What else you want?
సార్ ఇక్కడ అసలు క్వశ్చన్ లో V1 ఇవ్వలేదు కదా సార్, మన అది కూడా వేరే అవును
That is the source.
అది ఇవ్వలేదు కదా సార్,
వాడికి లేదు. నేను అందుకే V1 అని తీసుకున్నా.
ఆన్సర్ కూడా మనకు వేరే
అలానే చెప్పాలి ఆన్సర్. ఇఫ్ ద V1 is the source, V1 by 3 అని రాయాలి. అది ఏమని రాస్తాడంటే 1/3 ఆఫ్ 1/3 ఆఫ్ ద సోర్స్ వోల్టేజ్ రాస్తాడు. అదే రాశాడా? రైట్. అది కొంచెం బాగా రాయిలా లాస్ట్ టైంది హడావుడిగా వేసి ఇది కొంచెం నీట్గా రాస్తాడు. డన్. సో విత్ దిస్ ఐ విల్ స్టాప్. ఓకే.